Okay, I hope this is working. I'm trying to do this with the worst pollen attack so far of the year. Um, Pollen is really bad today. What we were doing last times, we were talking about circular motion and gravity. And if something's traveling in circular motion and it's going in a circle, there really is only one force acting on that object, and that is a force towards the center of the circle. That's the centripetal force, which happens to be the same direction as the centripetal acceleration. Now, it might feel to something that's moving in a circle like there's an outward force out. For example, if you're in a car and you make a turn, you might find yourself going in a direction that seems to press you outward. That's not really a force as much as it is inertia. So, as far as circular motion is concerned, the inertia of the object that's moving in the circular path is what's going to supply a pressing type of force outward. So if you have like a roller coaster that's making a loop, when the coaster's at the top of the loop, if it's going fast enough, the inertia, of this velocity going up is going to want to press the car up to counteract gravity, which is going to want to pull the car down. So you want to make sure that there's enough upward not normal force, but this is an upward pressure that comes from inertia pushing up to balance the gravity. Now I'd like to talk about tides. What causes tides is you have the moon, and then you have Earth. Earth we could think of as a big ball of water. And because the moon comes close to the Earth, from center to moon, center to the Earth, you could measure the gravitational attraction. So there is this force of gravity, which, let's see what color. How about this one? So points on the Earth that are closest to the moon are going to experience the greater pull of gravity. Points on the Earth that are farther from the moon, so let's say this is R1, and let's get another color here. How about this one? Here's another force of gravity at points this in the back of the Earth. This is points R2. So clearly the distance from the center of the moon to this region of Earth is closer, that's R1, is closer than the points from the center of the moon to this region of the Earth. So the FG in pink is a greater force than the FG in brown. So it's this difference, the difference in gravity or the pull of the moon at points on Earth that cause a bulging to occur, and hence when you have the Earth inside here, the tide's going to experience a high here and here. So what causes the tides is the difference in the gravitational pull of the moon at points on the Earth. There's a difference between the gravity experienced closer to the moon by this section of the Earth than the gravity experienced at this section of the Earth way in the back. That causes the Earth to stretch out. We call it tidal forces, and that's what causes the gravity. The tides. Now, as far as forces are concerned in gravity, if I have the sun and I have Earth, the sun is going to exert, let's do the sun in yellow. The sun is going to exert a pull on Earth in this direction. The Earth then, in turn, is going to pull on the sun this way. Sun exerts a force on the Earth exerts a force on the sun. If you're asked to compare the two, they are exactly equal. That is, the force of gravity of the Earth on the sun is exactly equal to the force of gravity by the sun exerted on the Earth. Gravity is gravity. And between any two objects, this gravitational force is going to be equal and opposite. So if you have Earth, here's Earth, and I have an apple on the planet Earth, and the apple, we said, weighs about 1 Newton, remember? So why not? The Earth is going to pull the apple with a force of 1 Newton. The apple will pull up on the Earth with a force of exactly 1 Newton. So as the apple accelerates, acceleration of the apple to the Earth is also going to accelerate to the apple, but the acceleration of the Earth will be very, very much smaller than the acceleration of the apple because the Earth's mass is so much greater, and the forces have to be equal. In other words, the force of gravity in either case is 1 Newton. And force of gravity is mass times acceleration. So if you have the mass of the Earth is really, really huge, the acceleration has to be small to equal that same 1 Newton force of the mass of the apple times the acceleration of the apple. So what does this all mean? It means that if the Earth is pulling the apple with a force of 1 Newton, the apple pulls the Earth with a force of 1 Newton. Since the force is the force of gravitational attraction between the apple and the Earth, they're exactly equal. If they're equal, and we know the masses are different, the accelerations have to be different. And of course, the apple accelerates at a greater acceleration to the Earth than the Earth accelerates to the apple. So that's about all I had to cover there as far as the questions were concerned that I wanted you to understand. And now we might do a couple of problems. So we'll do that in the next tape.